Hello students, welcome to my YouTube channel PKM classes. Today we study about a relation function. Now what is relation? Now relation, we know different types of relations: father, mother, brother, sister, uncle. These are the human being relations. And we take two lines, and two lines are either parallel, perpendicular, or in case of real numbers, two real numbers are equal. In this way, we know different types of relations are there. Now, what is relation? Relation is defined as subset of A cross B. If A and B are two non-empty sets, then the relation is a subset of A cross B. Now, relation. Suppose, let's take an example. A is a set containing elements 1, 2, 3, and B is a set containing elements also 1, 2, 3. Now here we find that A cross B is equal to 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Now, these are the elements of A cross B. If A is a non-empty set and B is a non-empty set, let A contains 3 elements 1, 2, 3, B contains 3 elements 1, 2, 3. So, this is the elements of A cross B. Let's take an example of a relation R1. R1 is a relation such that R1 xy such that x is equal to y. X is equal to y where xy belongs to A cross B. X belongs to A and y belongs to B. Xy belongs to A cross B so that x is equal to y. Now here we find 1, 1, 2, 2, 3, 3. So 1, 1, 2, 2, 3, 3, these pairs are satisfied the relation R1 xy. Now in relation R2 xy, suppose x less than y. Now this condition satisfied from A cross B, x less than y, 1, 2, here 1 less than 2, 1, 3 and 2, 3. These pairs are satisfied the relation x less than y. Other pairs are not satisfied x less than y. Now we take another example R3 xy such that x greater than y. Here we find x greater than y, the pair is 2, 1, 3, 1, 3, 2. These pairs satisfy the relation that x greater than y. Now take another example R4 is equal to xy such that x plus y less than 0. Now we find no pair of A cross B, such that x plus y less than 0. So we have no elements. That is 5. Now here we see that R1 is a subset of A cross B. All elements of R1 is also element of A cross B. So it is a subset of A cross B. And it is a subset of A cross B. Also R3 is a subset of A cross B. As null set of I is a subset of A cross B. So it is also a subset of A cross B. Now here we observe all relations are subset of A cross B. Hence the relation is defined as if A definition, let A and B are two non-empty sets, are two non non-empty sets. Non-empty sets. Then the relation R is a subset of A cross B, and written as R is a subset of A cross B. Now the relation, we see all the relations R1, R2, R3, R4 are subset of A cross B. Hence relation is defined as subset of A cross B. Any subset of A cross B is a relation. Now, if here we are two non-empty sets, relation is a subset of A cross B. Next, we know what is domain. Domain of R. Domain of R, that is equal to X, such that XY belongs to R. If XY belongs to R, then X is the domain. If the pair XY belongs to relation, then X is the domain. Now what is range? Range of pair is equal to Y, such that XY belongs to R. Next, what is inverse of R? Inverse of R, or that is R inverse is equal to Yx, such that XY belongs to R. If XY belongs to a relation, then Yx belongs to inverse of relation. Now we know that R1 is equal to 1, 1, 2, 2, 3, 3. Here the domain of R1 is equal to, now domain of R1 is equal to first elements 1, 2, 3. 1, 2, 3. And here range of R1 is equal to second entries 1, 2, 3. Hence range of R1 is equal to 1, 2, 3. And inverse of R1 is equal to, or R inverse, R1 inverse is equal to 1, 1, 2, 2, 3, 3. If XY belongs to relation, then Yx belongs to inverse. In this way you find domain, range of a relation. Now, in next we study what is the types of relations. There are four categories of relations. One is one-one relation, one-one relation, many-one relation, many-one relation, one-many relation, one-many relation, and many-many relation. Many-many relation. There are four categories, four types of relations. One-one relations, students or roll numbers are one-one relations. Husband and wife in one relation are one-one. Suppose fx is equal to x or y is equal to x, this rule is 1-1. A set contain ABC, B set contain 1, 2, 3, so that A related to 1, B related to, C related to 3, and the relation is 1-1. Distinct elements or different elements have different relations. Distinct elements have distinct mappings, distinct relations, hence it is 1-1 relations. Many-one relations, many elements of the first A, B, C, D, and related to A, B, C related to 1, D related to. So many of this first set related to one element of the second set. Now in the example, each square root of, suppose 2 is 2 or minus 2, 2 is the square root of 4, minus 2 is square root of 4, is square root of, each square root of is example of many-one relations. One many, each square of 4 is square of 2, 4 is square of minus 2, each square of, if one element of the of first set is related to many elements of second set, so it is called one-many relations. Next, many-many relations. The relation friend relations is example of many-many relations. Rama, Hari, Madhu, Gopal. Suppose Rama is a friend of Madhu, Rama is a friend of Gopal. Hari is a friend of Madhu, Hari is a friend of Gopal. So this relation, friend relation, is example of many relations. Is not equal to A set contain 1, 2, 3, B set contain 4, 5, 6. Now you observe 1 is not equal to 4, 1 is not equal to 5, 1 is not equal to 6. 2 is not equal to 4, 2 is not equal to 5, 2 is not equal to 6, 3 is not equal to 4, not 5, not 6. Here we observe that the relation is many relations. So there are 4 types of relations: one, many, one many. Now here in our course specially we include the properties of relations, that is reflexive, symmetric, transitive, equivalence. These relations are generally we teach here, we study the properties here in our syllabus, that is a reflexive relation. Now what is reflexive? A binary relation, reflexive relation, reflexive. A binary relation are subset of a cross A is called reflexive. Is called reflexive if A relation to A for all A belongs to set A. If A relation to A, the relation is called reflexive. Binary means the relation between two elements, two persons. The relation among two persons, we call it is binary. We know that relation is a subset of A cross B. So, relation is a subset of A cross A. It is called reflexive if A relation to A. Now, we take an example that is parallel to. Now, L1 is parallel to L1. So, A relation to A. L2 is parallel to L2. L3 is parallel to L3. L4 is parallel to L4. So, A is parallel to A for all A. For all lines are parallel to itself. You take a line L1, it is parallel to itself. So, A relation to A is satisfied. So, is parallel to in set of straight lines. Is parallel to in set of straight lines is example of reflexive relations. Next, is equal to. Now 2 equal to 2, 3 equal to 3, 4 equal to 4. So A equal to A equals to A for all A. For all A belongs to real number, A equal to A. You take any real number, it is equal to itself. So is equal to instead of real numbers on R. So reflexive relations is equal relation, parallel relations are example of reflexive relations. Congruent relation, any triangle ABC is congruent to ABC. So delta 1 is congruent to delta 1. Delta 2 is congruent to delta 2. Delta 3 is congruent to delta 3. So every triangle is congruent to itself. So is congruent to satisfy the property in relation to A. Relation here congruent. Similarly, delta 1 is similar to delta 1. Delta 2 is similar to delta 2. Delta 3 is similar to delta 3. So is similar to is equal to, is parallel to, all are example of replacive relations. Example of replacive relations are the relations satisfied. The condition A relation to A. A relation to A means A belongs to relation. If A belongs to relation, we say A related to A. But in human being relations, A is not father of A, so father relation is not replacive. A is not mother of A, so mother relation is not replacive. In our human being relations, so all relations are not replacive, as it is not satisfy the condition A relation to A. Next, symmetric. A binary relation, subset of A cross A, is called symmetric. Symmetric is called symmetric if A relation to B implies B relation to A for all A B belongs to set A, or that is, if A B belongs to relation, this implies B A belongs to relation. So you mind it that if a relation to B, we have to show that B relation to A. If this property is satisfied, then that relation is called symmetry relations. Example, is parallel to, let L1 is parallel to L2. So this implies L2 is parallel to L1. So parallel relation is example of symmetry relations. If A is equal to B, this implies B is equal to A. So equal relation is example of symmetry relations. If L1 is perpendicular to L2, so this implies L2 is perpendicular to L1. Now we see all the cases, if A relation to B relation here perpendicular, then B relation to A relation perpendicular. If A relation to B, B relation to A. So A perpendicular to B, B perpendicular to A. So this satisfies the condition. Hence, perpendicular relation is called symmetric. A equal to B, B equals to A. So equal relation is symmetric. L1 parallel to L2, L2 parallel to L1. So parallel relation is symmetric. Now, the relation which satisfies the condition that A relation to B, if A relation to B implies B relation to A, then we say the relation is symmetric. Next, transitive relation. Relation is transitive. A binary relation R, subset of A cross A, is called transitive. Is called transitive if A relation to B and B relation to C implies A relation to C for all A, B, C belongs to set A. If A relation to B and B relation to C, if this satisfied, A relation to C. Now take an example that here A, let A greater than B, B greater than C. This implies A also greater than C. If A greater than B and B greater than C, then A greater than C. So greater relation satisfy this condition. So greater relation is example of transitive relation. Again, if A less than B, B less than C, this implies A less than C. So is less than is also example of transitive relations. Again, if L1 is parallel to L2, L2 is parallel to L3, this implies L1 is parallel to L3. If L1 is parallel to L2, L2 is parallel to L3, now L1 is parallel to L3. A relation to B, B relation to C, A relation to C. Here relation is parallel. So parallel relation is called transitive. But in case of perpendicular, if L1 perpendicular to L2, L2 perpendicular to L3, So L1 is not perpendicular to L3. So perpendicular relation is not example of transitive relation. So if the condition satisfied that A relation to B, B relation to C, implies a relation to C, the relation is transitive. And the relation which satisfies all three properties, that is reflexive, symmetric and transitive. A relation satisfied reflexive, symmetric and transitive. If all conditions are satisfied, then the relation is called equivalence relation. A relation is called equivalence relation. Equivalence relation, if it satisfies all three properties, reflexive, that is A relation to A relation to A for all A, symmetric, if A relation to B implies B relation to A, B relation to A, transitive, that is if A relation to B and B relation to C implies A relation to C. If all the three properties are satisfied, the relation is called equivalence relation. Example, is equal to, is parallel to, is congruent to, is similar to, all are example of equivalence relation. L1 is parallel to L1, L is parallel to L for all L. So reflex. If L1 is parallel to L2, this implies L2 parallel to L1, symmetric. If L1 parallel to L2, L2 parallel to L3, L1 parallel to L3, as parallel relations satisfied reflexive, symmetric and transitive properties, so it is an equivalence relations. So in this way we find that the relation which satisfied all three properties, reflexive, symmetric and transitive, then we say that is equivalence relations. In next class we study the congruent modulo relation and its examples. Thanks.